Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. So now your modern data stack is set up. How is everyone going to find the data they need and understand it? SelectStar is a data discovery platform that automatically analyzes and documents your data. For every table in SelectStar, you can find out where the data originated, which dashboards are built on top of it, who's using it in the company and how they're using it, all the way down to the SQL queries. Best of all, it's simple to set up and easy for both engineering and operations teams to use. With SelectStar's data catalog, a single source of truth for your data is built in minutes, even across thousands of datasets. Try it out for free and double the length of your free trial at dataengineeringpodcast.com/SelectStar. You'll also get a swag package when you continue on a paid plan. Your host is Tobias Macy, and today I'm interviewing Stephen Goldberg about HarperDB, a distributed database engine designed to scale across edge and cloud environments. So, Stephen, can you start by introducing yourself?
For sure. First of all, Tobias, thanks for having me here. I'm really excited to be here. I'm Stephen Goldberg. I'm one of the co-founders, and I'm the CEO of HarperDB. My background is in enterprise data management, enterprise architecture, and large-scale integrations. I started my career at Red Hat. I've worked at a number of different startups and with a number of different companies.
And do you remember how you first got involved with working in data?
Well, I started programming when I was about 13. My uncle ran a startup in the Bay Area in the early 90s, and I started working for him there and then just kind of working for software companies. I think I got started in data and integration through work with implementing CRM systems, which often have a lot of integrations into other systems like ERP systems, billing systems, subscription management, inventory. And so I really started to run into my first set of challenges around data integration and data management through doing CRM consulting and implementation.
Now, as you mentioned, you helped to found and you're running the HarperDB company, which is also the business that is building and managing the HarperDB software. I'm wondering if you can describe a bit about what that is and some of the story behind how it came about and what it is about this problem space that made you want to dedicate your time and energy to it.
As I mentioned, I started my career doing, large scale business system implementation and integration. I actually met Kyle, my co-founder, who's our CTO, over 10 years ago. He was at a customer that I was doing implementation for, and we were doing some integration of Salesforce.com into some different systems. And I had been doing that at a lot of companies like Nissan and in a lot of different spaces. We had a lot of challenges there. About a year later, I started my own consulting company called CloudRoot. Kyle was my first hire. And at the time, Kyle and I thought that really we were interested in building a middleware technology to do sort of dynamic integration of different systems. This was before MuleSoft or Zapier existed, but we were kind of thinking of something like that because we saw that a lot of companies were experiencing the same challenges with integration. But we were trying to run a consulting company and build a product, and that's really, really hard. And so we kind of got acqui-hired into a different company where we were the engineering team, and we rebuilt all of their software and their back end. And they were focused on large-scale social media and analytics around sports and entertainment. So kind of like monitoring every single tweet about the World Cup or the Super Bowl or Beyonce concert. And so that was millions of rows of data a second. And we ended up building out this insanely crazy data infrastructure to manage all of that. And it was really hard and complex to manage. We spent most of our time just trying to keep the databases from crashing. We were spending a ton of money on the cloud and we weren't really getting to develop anything. And we also felt like databases were not very developer friendly. They were extremely focused on DBAs and infrastructure folks. And, if you're a developer, the first thing you need to do is get your schema together, get your database set up so that you can go build your app. But the databases out there were not easy to do as a developer. And so what we wanted to do, we got very frustrated with kind of what was available. And what we wanted to do was build a database that was the easiest database in the world to use, but that could scale to meet massive data challenges. And we came up with the idea one night while we were on a business trip. We were hanging out in an Airbnb in Palo Alto and we were just goofing around. And then we figured, hey, someone else will solve this problem. Someone else will build a database that has the scale of NoSQL, but with the analytical capability of SQL. It'll be super developer friendly. And, we're not database guys. We're not smart enough to do this. But you went to Stanford and has a PhD in data management and computer science will do that. And so we just kind of forgot about it, but it stuck in the back of our mind for almost 2 years. And we eventually just decided to do it. And we took a leap of faith 5 years ago today. Today's actually the 5th year anniversary of HarperDB. And here we are. I think we've lived up to what we were trying to do, but it has not been an easy road to get here.
That's pretty funny that it's 5 years to the day that we happen to be recording this interview. So I'm grateful to be able to spend that time with you. And as you mentioned, you don't have the background in sort of database systems and the theoretical underpinnings that go into it. And so I'm curious how you've approached the process of being able to design and build a database engine that has these fairly extensive requirements and capabilities, and being able to make that developer friendly, and just some of the overall process of understanding how to approach such a large and thorny problem.
I think that I, often underestimate the complexity of a problem and I get very excited. And so my excitement and eagerness sort of got us all to jump into this problem that we didn't really understand. I think ultimately that is a lot of the reason why we are successful and why we've brought something unique to market is sort of Kyle and I were too stupid to know what we were doing. And so as a result, we kind of felt like, hey, an iPhone is a very complex device, but it internalizes that complexity and it exposes simplicity to the end user. Databases should be able to do the same thing. And so we sort of lived with this mantra that keep it simple, stupid. And, we wanted the interfaces to be simple. Like we have a REST API with one endpoint that just accepts a post body and you change the JSON of the post body. We tried to make it so that it was as simple as possible, but to do that, to gain performance, to gain scalability, to gain consistency, we had to educate ourselves a lot. And I'll be honest, at a certain point, I realized I was well outside my technical depth. But Kyle really embraced that challenge. And he's basically, over the last 5 years, given himself a PhD in database systems. And he's probably one of the most educated people in the world about them now. But he spent the last 5 years, sort of trying on different things, moving fast, seeing what fits, moving on to the next thing. And we made a ton of mistakes along the way. Our first version of the product was written on the file system, and a lot of people told us that was insane, and we did it anyway, and it didn't work. We're now, we've rewritten the product so it's on top of LMDB, which is a lightning mapped key value store built by Howard Chu. And, that was a huge learning. We wrote the first version of the product using Socket IO as our clustering mechanism. Then we had to move to Socket Cluster, and now we're moving to something else, which we'll talk about in the future once it's publicly available. That's even better. But we've made some mistakes, but those mistakes taught us a lot. And we've sort of focused on, while we're doing all these very complex things, make it simple for the end developer so they can just write their code. They don't care about database. They're not geeking out about how cool all the internal complexity is. They just want to throw some Python or Node.js or whatever code around a REST API and focus on the thing they do care about, which is their application. And we try to make it so that they can do that without really even having to worry that much about the database or how it works.
Yeah, it's always pretty remarkable what you can achieve when you didn't know you're not supposed to be able to do it.
Yeah, I don't know that I would do this again, but our stupidity was probably the biggest key to our success. But now I have a lot of gray hair in both my beard and head from it, but that's okay.
And Over the past 5 to 10 years, there's been a pretty remarkable explosion in the availability of different database engines with different areas of focus and different technological underpinnings. And they all have their own particular niche that they're trying to address. And I'm wondering if you can just give the framing of what HarperDB is designed to do well. You mentioned the developer friendliness, but from a sort of database engine storage management perspective, what do you think are the unique capabilities that HarperDB brings that will edge out a MongoDB or a CouchDB or a Postgres?
So one of the reasons we started the company is that we were kind of frustrated by the notion that you need 5 to 7 different databases to be the infrastructure for an application. When I started programming, you had Oracle, you had MySQL, you built your app on that, and you figured the rest out. You didn't spend millions of dollars on databases and managing them and integrating them and having your data be out of sync. And so we kind of built HarperDB to be the new workhorse like MySQL was back in the day. And that it's not the best at everything. Like, you take a product like VoltDB, which is an in-memory product, and you definitely can do reads at scale like faster than HarperDB. But if you're trying to do reads and writes, Volt's going to crash at a certain level. And so we kind of said, hey, let's build a workhorse that's solid as a rock, that's never going to crash, and that you can do everything you want to do. It may not be the best, but it'll work for almost every workload. That said, while that was the goal, and it still is true, and for developers and for building applications, that's why I think it's an awesome fit. Where we've found that HarperDB really does have the most competitive advantage, really is like at an enterprise level, the best fit is for low latency distributed applications. So if you think about something like a gaming use case where you've got end users all around the world, it's really easy to distribute your APIs, to distribute your application. Containers make that super easy. But all those APIs in your application still ultimately are going to call back to a centralized database. And physics makes that a problem because you can only get from Tokyo to, Ohio at the speed of light, which for a lot of applications doesn't matter, but for other applications it does. And that adds a lot of latency. And so by distributing HarperDB all over the world, having it be super fast at a node level, it's really great for those distributed use cases where latency does matter, where you want to, reduce costs. So that could be gaming, streaming media, other use cases like that are a really great fit.
In terms of the focus on being accessible and pleasant for developers as the target end user, how has that influenced the ways that you've designed the interfaces and feature capabilities of HarperDB?
We are developers and we built a database for developers. Like I said, we don't have PhDs in data science or anything like that. And so we really thought about it. We're like, if we wanted to use this, what would it look like? And so at our last company, we had a lot of APIs in our product, hundreds of APIs, and it was super hard to maintain. It was super complex to find what you're looking for. And so that goes back to what kind of I already mentioned. HarperDB, if you're running it locally, is localhost, :9925 /, and it's always that. And you always hit that with your post body. And then if you want to do like a NoSQL search, you put that as the operation in your JSON body. If you want to do a SQL search, you put that in the operation. So it makes coding super simple. We've also partnered with companies like Postman, where you end up getting all these awesome libraries that you can use. And we've also started a bounty program where we pay developers to build add-ons to HarperDB, like different SDKs, different applications. And so we've just really always focused on our end customer being a developer, whereas a lot of other databases focus on their end customer as a DBA, which is great for that DBA, but it's not ideal when you go to write code on it. And so also have really focused on this idea of collapsing the stack. And so as a developer, like the less tools I have to use behind my application, the better and the easier my life is. And so that's why we rolled out things like custom functions where you can write your own application code right in HarperDB, right next to your data, and manage and build an entire application right on top of HarperDB without anything else. There was a product back in the day called Heroku, which I really liked and did a lot of that. And then they were bought by Salesforce.com, which kind of made them less ideal for most applications outside their ecosystem. But a lot of that concept was in their product. And SAP HANA honestly tried to do something similar, but really more focused on their ecosystem. We wanted to build sort of a development platform and database all in one that you could build your entire application on, that was a more generally available thing for everyone outside of any ecosystem. And that's kind of what we've done to make developers' lives easier.
Yeah, there's definitely been a fairly cyclical view on the role of the database in the overall stack of software and sort of application delivery, where for a while it was the 3-tier architecture where you had your load balancer, your web application, and your database. And then, there have been approaches of push all the logic into the database, have that be the actual runtime for your application as well. I'm wondering what your thoughts are on the role of the database over the next 2, 5, 10 years, and how your thoughts on that have manifested in the way that you've approached the design and functionality of HarperDB.
Yeah, I think that goes back to your other question, which was, now that there are all these databases with all these different niche, I think it was kind of laziness on the part of a lot of companies to say, hey, we're going to make this niche thing, and you as the developer then have to niche together 5 to 7 databases and 5 to 7 different middleware tools and 6 to 7 different other technologies. That is unfair. No one wants to do that. And I think that was a trend for a while, but I think that a lot of top to bottom, whether you're an entry-level developer or you're a CIO or CTO, I think that's become frustrating. I think that people, are moving more towards managed services and APIs. They want infrastructure as a service, infrastructure as code. And I think that people want things to work together. I think they want it to be more seamless. And I think the trend you'll start to see is some of these very niche offerings that, yes, maybe they're really good at one thing, but that is a whole expense and team and complexity and resources. Do you really need that? Is it justified? I think people are getting smart about that and starting to realize that they would, like to have tools that are interoperable and that can be used ubiquitously. And I think that you shift more towards products that are successful where they fit that pattern. And that's why we've added custom functions. It's why we have SQL and NoSQL. It's why we have JDBC drivers while also having WebSockets. It's why we're trying to accommodate everything that the very small startup would want all the way to the extremely large enterprise, so that you can have all of that in one place. And with our custom functions, you really can code anything. You can do machine learning. You can do a front-end website. You can integrate into a third-party system. You can manage sub-processes. You can build your own APIs. So I know that doesn't work for every use case, but I think that there's a lot there that solves for. And I, as a developer, that's what I want. And I think at least some of the market is like me.
One of the things that I often run into as an engineer when I'm starting to play in some of these different ecosystems is particularly when you have a kind of collision of concerns that isn't as widely adopted in industry. So as an example, when I was going through your documentation, one of the options that you have in your API is being able to actually write a SQL query as part of a API request to the database engine. And so if I'm trying to develop that as an end user in my IDE, I might get some support for being able to highlight the SQL syntax to see, do some linting to see where it's wrong. But then if I try to embed that into a JSON structure, then I'm trying to sort of collapse too many concerns into one, and the tooling doesn't always support that well. And I'm curious what your thinking is in terms of being able to effectively kind of collapse those concerns into a single experience, provide a good experience to the end user, being able to have all of the different tooling and ecosystem capabilities that they're used to, and wrap that all into a single product that is sort of easy for people to pick up and use, but doesn't force them to maybe switch the tools that they're used to developing with.
I think that is a really good point. And I'll give you an example. So when we first started the company, first couple months, Kyle and I were designing what searching would look like in NoSQL. And we started working on adding multiple conditions and multiple operators. And we started to end up with this JSON object that was a mile long. And I just looked at Kyle, and our whiteboard was covered. We looked like the guy from Beautiful Mind, and like we were just crazy. And I looked at him and I said, there's a really good way to do complex searching that's been around for about 40 years. It's called SQL. And trying to do this is insane. Like, asking a developer to understand the syntax that we're building here is just crazy town. And so we have always kind of adopted it, just like when things get too complicated, stop. And that might mean that we're going to make some trade off from a performance perspective or from a feature perspective, but there are other products. Oracle has 40, 50 years of crazy features in it. And if you want to go do some sort of really complicated SQL query that has a trigger and, some sort of cascading delete afterwards and with a stored procedure, go for it. But that's like not what we're trying to achieve. And so part of it is just staying true to what we built. But sometimes we make mistakes, right? Like we've made mistakes, like you mentioned in the SQL piece. And so then that's why if you go into HarperDB Studio, you can see we do have some of that built in the UI. And then you can also use database management tools like the MySQL Workbench and things like that on top of HarperDB if you use ODBC or JDBC drivers, because we don't want you to have to learn new stuff. Like we don't want you to have to learn HSQL. That's why we tailored the ANSI standard. We don't want you to have to learn, new things. We are trying to make your life as easy as possible, while also knowing that when you have a billion rows a second being written, that HarperDB will still work. Because a lot of times it's what's easier and developer friendly on one side and what's enterprise grade on the other. And that's not fair. And so we're trying to do a balance between much as both as possible, but it's hard. And we get in fights about it. Jackson's our head of product, and Kyle and I will get in arguments. And it's normally Jackson and I arguing with Kyle because Jackson's tagline is like easy button and mine is keep it simple, stupid. And like Kyle's very focused on performance and scale, and we fight it out and then hug it out and come up with a good solution is kind of our answer.
I definitely appreciate the availability of the studio solution as a way to unify that experience and have a kind of first-class interface into the engine for people who do want to lean heavily into HarperDB as a platform opportunity.
And I have to say that was all Jackson. Kyle and I never thought of that. We didn't think it was important. And Kyle and I, our background is in integration and, data management. And so UIs were like command line and REST API. And so Jackson has brought that experience to the table, and we're very lucky to have him.
Today's episode is sponsored by Prophecy.io, the low-code data engineering platform for the cloud. Prophecy provides an easy-to-use visual interface to design and to deploy data pipelines on Apache Spark and Apache Airflow. Now all the data users can use software engineering best practices, Git, tests, and continuous deployment with a simple-to-use visual designer. How does it work? You visually design the pipelines, and Prophecy generates clean Spark code with tests and stores it in version control. Then you visually schedule these pipelines on Airflow. You can observe your pipelines with built-in metadata search and column-level lineage. Finally, if you have existing workflows in Ab Initio, Informatica, or other ETL formats that you want to move to the cloud, you can import them automatically into Prophecy, making them run productively on Spark. Learn more at dataengineeringpodcast.com/prophecy. Digging into HarperDB itself, can you talk through some of the implementation and some of the ways that the design and goals of the engine have changed or evolved from when you first started working on it?
The goal of read-write performance, simultaneous read-write has always been there and something we really excel at and continue to get better at. But touting our replication capability was not something we ever really thought that we didn't start out to think, hey, distributed is an area that we're going to excel at. To be honest, because we wrote the product in Node.js, we just kind of fell into that because it's a web framework and the web is very good at horizontally scaling and Node is extremely good at horizontal scale. And things like Slack were built on socket.io. And when you think about it, that is an extremely distributed system. And so we inherited that off the shoulders of people like Slack. And that then became a major selling point for us. On the flip side, we really thought things like JDBC and ODBC drivers would be super important and no one cares. Like they use it to test stuff out and like maybe they'll connect it to Tableau, but like realistically, people just don't care that much about them. Like we could get rid of them tomorrow and I think like 5 people would complain of the 25,000 some people using HarperDB. But Kyle and I were so obsessed and thinking that was going to be so important. So it's interesting. But then you'll have a customer who's really important who does care. And so we're glad we have them. But we definitely didn't do enough market research on what people would care about and not in the beginning.
As to the data model, I know that it is designed to be very flexible and dynamic in terms of the schema definitions. And I'm wondering if you can talk to some of the ways that you've approached the actual underpinnings to be able to support things like joins, given your investment in SQL as an interface to the database, because I know that for document-oriented databases, it can become very difficult to actually do performant joins across different document collections, and just some of the edge cases and engineering challenges that you've run into as you've been developing this database.
Yeah, I mean, that was ultimately the problem we solved from day one. And so we've really stayed true to that. The reason was we were using DynamoDB at our last company, and we had millions and millions of rows in DynamoDB. And it was great for scaling up for writes and doing simple searching. But then, trying to join or cross things was hard. We looked at Hadoop and Hive and things like that, and super slow. And we tested a bunch of other stuff. And so ultimately, the solution that we ended up having in our last company was we'd capture everything in Dynamo and we'd move it over to an in-memory SQL database to do all the analytics. And that was just super annoying to us. And it got out of sync because we were doing all this stuff real time for live television. And so if it was out of sync for a minute, we couldn't go live on broadcast. And trying to sync two databases with a billion rows of data in them within a minute is hard. And so that was sort of the impetus of creating HarperDB. So our storage algorithm is a document store, but it is different than most other document stores. At a high level, the way it works is it is not an unstructured database, because as you insert data, we dynamically look at that data and we index all top level attributes on write. So then as a result, combining a column from table A versus table B, querying those two columns is about the same performance as querying two columns from just table A because of the way we store data. And the goal of that was so that you don't have to know what your schema is going to look like at a time, but whatever analytics you want to do on it, HarperDB has indexed in a smarter way possible that's possible. And so everything is indexed, which creates some challenges around storage, right? Like your storage is a little higher than it would be with some other stuff. I think it's about 20%. My cousin is a developer at a very, very large social media company, and he's a lead Android developer there. And he once asked one of the teams, he said, "Hey, I need to be able to query on date of birth because we need this content to be 18 plus. And they said, "Oh, we didn't index that column, figure out a different way because it'll take us a month to do that." And as a developer, you don't want that answer. You want, just give me the column, I want to query it. And so that is kind of why we designed the storage engine the way we did. And it has its trade-offs, but it makes developers' lives a lot easier. And, you can never predict what you're going to need till it's too late. You have several billion rows of data in there and you want to be able to query it.
One of the complexities that can often occur when you do have this dynamic schema is that one time you have an application that's writing in this structure and one of the fields is an integer, and then somebody makes a code change and now it's writing out a string value. And I'm curious what types of enforcement you have for being able to say, okay, nope, this was an integer. You can't write a string there anymore. You're going to have to actually pay some attention to the data modeling. Or is it just write whatever you want and we'll figure it out later? Because there are definitely pros and cons to both approaches.
We have some intelligence. We do not force anything right now. And so you can do whatever you want. You can put a string and an integer in the same column. We do have some intelligence around the indexing, and we'll look at what the majority of that is there and we'll sort of store it based on what we think that data is. But ultimately, you can still do whatever you want. And so we felt like that was a decision that allowed you to still have the flexibility of NoSQL, but with better performance than you would get from NoSQL. We do have things built into like the ODBC and JDBC drivers where it'll look at the columns and it'll take its best guess so that when you pull in the Tableau, it's like this column's an integer, this column is a date, this column is lat long. but we don't enforce anything right now. We do plan to in the future, when we have some more resources and time, allow that as an optional feature where you can turn on schema enforcement. But the nice thing about HarperDB is you can describe the schema. And so unlike MongoDB, where you'll have a million rows that have this column, but in the same collection, you might have a million rows that don't. Once that column's created, it's created. And it's there for all the objects, and it'll be null if you don't put anything in. And whether or not you have it, it's there. You can describe the schema, see what it looks like. So you have some better management around that. But yeah, we're kind of trying to balance that. And it's a hard thing to balance because as soon as you turn on strict schema enforcement, that's going to create a whole nother set of problems. And so, we also strongly believe in keeping HarperDB as stateless as possible. And so we're also very wary of ever putting background processes in, because background processes are often what cause databases to crash. And so there's a lot of things that go into that thought process. And it's not as hey, we don't want to do that, as much as there are so many trade-offs in a database when you make one decision that you really have to carefully think about everything. And then also, databases are a hard thing to update and maintain. And so we can't just roll out features willy-nilly, because that can be extremely disruptive. So things have to be really thought out before we do them. This exact problem you're talking about is one of the things we've been talking about for years, and carefully planning how we'll roll that out.
Another interesting architectural aspect of HarperDB is, as you mentioned, it is a distributed database engine. And I know that the replication method is using a pub/sub model where you can subscribe to different table updates and decide when to replicate that. And I'm curious what types of deployment topologies and unique use cases that enables, and just some of the ways that that has manifested in the overall sort of product design of HarperDB.
Yeah, that gives a lot of optionality, and with a lot of optionality comes a lot of trade-offs. And so there are not infinite, but there are a lot of different topologies in which you can deploy. So you can do a hub and spoke, you can do a circle, you can do many, many different ways. You can have a multi-tiered hub and spoke. And so it very much depends on the use case. In IoT, we've seen a lot of the hub and spoke be sort of like a successful model. If you think about it, you've got things writing very high volumes of data on the edge, but maybe as you get closer to the core, that data doesn't matter that much. And so you want to kind of buffer, decide, and sort of have a multi-tiered architecture in how your data moves, from the edge into the core. Then you've got more like gaming media where all of the data matters all the time. And so some smarter version of a circle makes more sense on a fully distributed, peer-to-peer. It is extremely use case dependent, but you also have to think about what that means, right? Because it is an exponential problem, because as you add nodes and those nodes talk to each other, if you have 100 nodes, that's 100 connections you could potentially have. And then what does that do to your network, and how much information is moving back and forth? And so that is why we are actually rolling out, and I can't unfortunately talk about it too much, but we're rolling out a new clustering topology which solves for a lot of that, makes things also more consistent across that. Because what we've realized is that while that optionality is great and we're going to keep that, we need a more standard methodology to keep people safe, honestly, because sometimes choice can be a problem. And so it is a really interesting problem. And I'll be honest, Kyle is much smarter about that than I am, and can talk to your head off about it for 4.5 hours. And it's a very geeky, cool problem, but it gets pretty complicated between network and also available compute on a per node level, and open connections and things like that. It is one of the two most complex engineering problems in HarperDB besides the storage algorithm.
Yeah, and particularly when you start dealing with replicated data structures and figuring out what are the transaction boundaries. Do I want to actually get into the space of doing distributed transactions, where I know that with HarperDB you have opted for last write wins, and so whichever record ends up being replicated to a given node, whichever one was the most recent one is going to be the winner in that sort of write competition.
Yeah, and we did that on purpose because the use cases that we're working with, that is probably the best way to do it. But that doesn't work for other use cases. And Cockroach, it's weird because we're sort of competitive with Cockroach, but we'll often recommend if this doesn't work for you, you should look at Cockroach DB because Cockroach does a really good job of solving the other side of the problem for us. And they're a much better fit for sort of like a fintech use case where that really matters. And obviously, we're going to be much faster than Cockroach in a distributed fashion because we did the other side of the problem. And so we focused on speed and lower latency for the end user, but the guarantee of consistency is going to be lower. And whereas Cockroach is focused on that guarantee. And so, like, you have to decide what you want. And if you're looking for that guarantee, Cockroach is a better choice than HarperDB for that.
In the context of the deployment topologies, you referenced IoT, and I'm curious, what are the available deployment targets for HarperDB, and how has that influenced the way that you think about the actual packaging and deployment of the database engine to be able to potentially fit on some of these smaller or lower powered devices?
So we spend a lot of time working in IoT. HarperDB can be deployed on anything with a Unix-based operating system. So your Mac, a Raspberry Pi Zero, a huge bare metal machine, and kind of anything in between. And so we spent a lot of time in the beginning focused on it has to be able to do everything on a Raspberry Pi that it can do on a Cray supercomputer. To be honest, we spent too much time worrying about that because the way that IoT has moved, we're partnered with Verizon now and we're deployed on all of their MEC locations throughout the United States. And so, like, we're doing projects with them where you have smart devices over 5G talking to HarperDB on, wavelength locations spread across the United States. And that latency from that device to HarperDB on that MEC is like typically 1 to 2 milliseconds, maybe 5, 10 in worst case. And we've realized that for IoT, that's a way better pattern is just, having more edge data centers closer to the end user makes a lot more sense. Definitely putting some application on the device, but the more you put on the device, you create a lot of risk. And also then you have like problems with upgrading devices. We're looking at one customer where if they were to upgrade their devices, it would cost them $100 million. And so moving that compute as close to that device as possible and putting as much logic in HarperDB custom functions in HarperDB really solves that problem without creating these risks around putting it directly on the device. That said, if you want to run it, there are use cases more specifically in areas where you have poor connectivity, and that will remain that while for a long time. Those could be utilities, industrial use cases, military use cases, where you can install HarperDB on a mobile command center running, on the battlefield. And so we still solve for that, and we still have a lot of capability because HarperDB works totally offline, doesn't require the internet, and can run on those devices. And there can be value in that, but that is not sort of our primary focus, but still something we're able to accommodate.
There are definitely a lot of interesting sort of subtopics we could dig into, such as the kind of versioning and updates of the function definitions, some of the ways that you think about the kind of design and capabilities of those embedded functions, the sort of upgrade process of managing HarperDB deployments. But another interesting element is the fact that you do have this open source database engine and this commercial entity behind it. I'm curious what the sort of governance and sustainability approaches are for being able to manage the boundaries between that open source and commercial capabilities.
So HarperDB itself currently is not open source. So the core of HarperDB is a freemium premium model. I'm a former Red Hatter. I'm a huge fan of open source, and we've tried to open source as much of the technologies we possibly can, and everything surrounding it. One of the things when we launched the company we looked at, and actually we looked at Cockroach quite a bit, was that launching an open source database was hard. No one wanted to pay for a database. And I would love HarperDB to open source. I think honestly it would help us quite a bit. We'd have a lot more people contributing to it, be in the hands of more people. It's written in Node.js and it's deployed via NPM, which are two of the most popular things in the world. So I think that would go over well. But we also need to be a sustainable company and grow and get paid. And so that has been just a real balancing act for us. We constantly think about open sourcing HarperDB completely. And hopefully we get to a point where we can do that, but we're not quite there yet. And I don't know that we ever will be, but we would love to, I guess, is the honest answer.
In your experience of building the HarperDB technology and the business around it and working with your customers, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
So many. So one time, and I mean, this is very old, but I remember a guy in a rural area in India built an application on HarperDB where he could do legal document sharing. And so basically, he would pass the database around on these devices so that they, without internet, had this ability to sort of track for consistency and manage that and do version control, but offline completely. And I thought that was really interesting. I think gaming companies have pushed us into some really interesting areas around doing things like fighting bots at scale on HarperDB, use peer-to-peer capability. We've seen projects with the US military where they've done like facial recognition stuff inside of HarperDB, which I thought was fascinating. People are constantly just building really cool stuff on it. That's one of the fun things about being a database is that the community builds a crazy variety of different things. It's honestly for Kyle and I probably the most fun thing is every time we see somebody build something new and wild on HarperDB, it's like, hey, we built that thing under that, and now they're building that. And it's like the most affirming and most fun part of running HarperDB.
In terms of the features and capabilities of HarperDB, it's a fairly extensive project. I'm curious, what are some of the capabilities that you think are either overlooked or misunderstood or underutilized that you want to highlight?
I think this sounds stupid, but it is true. I think really for me, it's two things. I think one, when we talk to a lot of companies, they believe it's going to be this tremendous migration process to a new DB because they're used to sort of JDBC drivers and ORMs and all of that stuff. And HarperDB, because it's a single endpoint and you can literally copy the code examples in any language, building an app on HarperDB, and any developer that's ever done it will tell you is it's easier to build an app on HarperDB than anything else in the world, but it's because it's that single endpoint. I don't think people really understand what that means until they use it. And so that's something I think that people need to get their heads around, but when they do, it is a huge value add. And then I think how extensible custom functions make HarperDB. It's a fast device server essentially living inside of HarperDB. And what that means you can then do. I think people, they're starting to see it now and are blown away by it. But I think that that's going to take some time to catch on. I'm excited to watch that catch on. And I saw a tweet from a guy yesterday and it was like, I built my whole app on HarperDB. I did not believe that I could do that, but then I did. And that was very cool to see. So we're excited about that.
In your experience of running the business and building the technology and working with the community around it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think one thing we learned was that the developer community, we love them and they drive a tremendous amount of innovation and value to us, but they are not they don't pay us money. And so trying to target both the developer community as well as the large enterprise has been tailoring our message and our documentation and our feature set to accommodate both those folks at the same time. That was not something we expected, and we had to learn a lot about. I think that's probably been number one for me.
We've touched on this a little bit with some specific examples, but broadly speaking, for people who are interested in being able to build on a flexible and scalable database, what are the cases where HarperDB is the wrong choice and they might be better suited with a different engine?
I think fintech is definitely one. I think if you're primarily building something like a data warehouse and you have low volumes of writes and you're just doing massive reads on huge volumes of data, you're really not looking for like an HTAP database where it's both an operational database as well as an analytical database. HarperDB is probably not a great fit for that. There are better things to solve that problem. Yeah, those are kind of the two major ones. I think like if you're looking at Splunk and comparing HarperDB to that, Splunk is definitely going to have like more features for analytics than we will. If you're really focused on solving one problem and the benefit of being able to do everything in one place isn't there for you, you don't care about that, then it might not be the best fit. But if you want to solve one problem and be able to do most other things, then HarperDB is a really solid fit.
In terms of the near to medium term future of the project and the business, what are some of the things that you have planned or any projects that you're particularly excited to dig into?
As I mentioned a few times, we're rolling out a new version of the replication engine, which I'm super excited about. That's going to be in our upcoming release. We've spent a lot of time doing hardening. I think we're going to continue to enhance custom functions. I want to start rolling out like a library of pre-built stuff for the community on custom functions that are sort of ready to go. So that's something I'm excited about. We've had some great sort of live streams and web streams recently that I think were pretty exciting. We have several more coming there. And we're announcing some really big partnerships that I think are going to make HarperDB even easier to use and give developers more flexibility about where they deploy their applications. And so we're very excited about that as well. And those are from all the way from the 5G edge to sort of hyperscaler cloud and everywhere in between. And so I'm pretty excited about those as well.
Are there any other aspects of the work that you're doing at HarperDB or the database market or the use cases of building your application logic in the database engine that we didn't discuss yet that you'd like to cover before we close out the show?
I did think of something just now and sort of relevant to that. That's around what's an overlooked feature, but that also ties in this question. I think the other thing that people don't realize and that I even forget is HarperDB is decoupled from its storage and it treats containers as a first-class citizen. That is very unique to HarperDB in the market. And so from a deployment perspective, when you want to deploy your app, you can deploy HarperDB on Kubernetes and attach it to storage, and it's started in a few milliseconds, detach it and deploy it somewhere else and reattach it to storage, and it's up and running in a few milliseconds. So as the world moves to infrastructure as code and containers become the norm, I think HarperDB is probably the most container-friendly database in the world, and I think that gets often overlooked, and I think will become like a very interesting part of our story in the near future.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
That's a great question. Storage is the answer, and it's an easy answer. Compute is very flexible now, but storage is not. And storage needs to be disrupted. And honestly, if I wasn't doing this, I think I'd do that, but I didn't know that before this. So I'm just learning that. It's very frustrating, the available storage options in the market. And unless you're inside of AWS or GCP or Linode, it's very hard to have flexible storage options outside of the hyperscaler clouds. I think that makes data management really hard. And right now is only affecting the very large players in the space who have huge volumes of data. But as everyone starts to have huge volumes of data, I think that's going to be a problem that needs to be solved. I highly recommend someone start a startup and disrupt that space.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at HarperDB and your overall perspective on the database market. It's definitely a very interesting project, great product. Definitely excited to see the capabilities that you're offering to the community. So I appreciate all of the time and energy that you and your team have put into that. And I hope you enjoy the rest of your day.
Thank you so much. And I really appreciate it. And thank you for having me here.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.